Welcome back. Section 10.6 Conic sections in polar coordinates. Let's start with a theorem. Let f be a fixed point on your coordinate plane. Let f be a fixed point called the focus and L be a fixed line called the directrix. In a plane, let E be a fixed positive number called the eccentricity. The set of all points P in the plane such that distance of P from the focus over distance of P from the line directrix equals E, the eccentricity. That is the ratio of the distance of P from F to P from L is E. The set of such points is a conic section. The conic is an ellipse if this E is less than 1, is a parabola if E equals 1, it is a hyperbola if E greater than 1. So notice if E were less than 1, then distance of P from F is less than distance of P from L. If E equals 1, then distance of P from F is equal distance of P from L. If E is greater than 1, then distance of P from F is greater than distance of P from L. Okay, let's look at the proof. If E equals 1, then this ratio, distance of P from F to distance of P from L equals 1. Multiplying across, you get distance of P from F equals distance of P from L. This is the definition of a parabola. Now suppose, without loss of generality, okay, to understand more, suppose the focus is 0, 0, the origin. The directrix is a line x equals d, so it's a vertical line. And you have a point here P whose distance from F is denoted by R. All right, so what is happening here? Distance of P from F is R in polar coordinates. Distance of P from L, that is this distance, is all of this distance, which is d, because you see here x equals d. This total distance minus this particular distance, that is the distance of P from L. So notice this distance equals total distance minus this distance. Okay, the total distance by definition is d. That's what is x equals 0 here and x equals d here. What about this distance? This is r cosine theta. All right. So the distance of P from L is d minus r cosine theta. Moreover, the ratio distance of P from L over P from F over P from L is E, implies distance of P from F equals E times distance of P from L. So this is R equals E d minus r cosine theta. Notice what is r squared? X squared plus y squared. So r squared, on the other hand, if I square this, I get E times d minus x, that is r cosine theta is x, quantity squared. So E squared and d minus x squared, that is d squared minus 2dx plus x squared. Distribute the multiplication, you have E squared d squared minus 2e squared dx plus e squared x squared. So x squared plus y squared is all of this. All right. So you have x term here, x term here. So what do? We bring this term out here, this term out here, and keep the y squared. So that is, you brought x and y terms together on the left. Once you do this, x squared minus e squared x squared is 1 minus e squared x squared plus 2 e squared dx plus y squared is e squared d squared. Divide throughout by 1 minus e squared. When you do that, you get x squared plus 2e squared dx over 1 minus e squared plus y squared over 1 minus e squared equals e squared d squared over 1 minus e squared. You are basically completing this as a squared, so the coefficient of x over 2 squared you need to add to both sides. If we add that quantity, e squared d over 1 minus e squared quantity squared, you see, for the purposes of completion of the squares. So I add this quantity to the left, I add the same quantity to the right. So these three terms is a complete square, x plus square root of all of this, that is e squared d 1 minus e squared quantity square plus y squared over 1 minus e squared. Take this, get common denominator and proceed. When you simplify all of this out, you see, you get the following description. When e is less than 1, this quantity is anyway positive square. Because of the square, it's a positive. E is less than 1. You get, now you divide the right hand side throughout. Okay. So this looks more and more like what we are used to, conic. So this is an ellipse. Okay. So what is the story? H is negative of this quantity. You write it like that. All of this is a squared. All of this is b squared. So you can see this is a shifted ellipse. All right. So okay, for an ellipse, c squared is a squared minus b squared. So that's a, that's b. A is here, b is here. When you simplify all that, c squared turns out to be h squared. So c is negative h. All right, plus or minus h. Well, you take negative h to write in this fashion. Moreover, c over a is e. When e is greater than 1, notice e greater than 1 makes this a negative quantity. And that's when you have a hyperbola. Let's check it again. Here, this becomes negative. When e is greater than 1, this quantity becomes negative. All right. So because of this. So you get a hyperbola when e is greater than 1. All right. So now we'll come to case 1 in a minute. Next video.